Where are you sitting?
Me? Oh,
I want to sit right next to you.
Okay, here. I think I'm sitting there. I know who that is.
I can sit back. I don't know what I'm doing up front.
Now you I don't have to do the presentation, do I? Yeah.
You're really close to the presenter.
I haven't prepped at all.
That's okay. Someone was told he was doing the presentation, and he goes, "What?"
I came for moral support.
That's not what it sounds like to me. Sounds like Mark was handing off the baton.
Yeah, he's a funny guy. Let's do this, Mark.
Okay.
Yeah. You just defer to me when you get stuck on one of these concepts. You got it.
All right, so this is our June continuing education, and today we have Mark Edhammer, Principal Engineer for Southland Industries for the Northern California Division. So he's going to give us our talk on basic concepts of HVAC.
Well, I got a bunch of slides here, so I'm trying to go through them quick. And just yell, they're probably pretty boring to y'all, but I think my goal, I kept it real basic, is just kind of look, if you're walking a roof, or you're walking a building or whatever, what you see and kind of tell you what it is. Probably half of you have seen it already. Again, I'm trying to keep it basic. I have 58 slides, so I'll probably cruise through a lot of them pretty quick. And my first slide will tell you how basic I'm going here.
Minute a slide.
I'll go for it.
You want questions during or after?
Okay, we're going to go.
I guess whatever you guys want.
This is pretty basic.
Push the button and go forward.
You can hit spacebar. Hit the spacebar.
There we go. Okay, what is HVAC? You know what? It scares me. I hire mechanical engineers who don't know this. So it's heating, ventilation, air conditioning. So just a quick system. Again, I'm not trying to educate you. So you basically in a room. So we collect the heat here and reject the heat. Is one. Evaporator collects, condenser rejects. You got some expansion. Stop it. So this is where you walk the roof. You got the fan blowing heat out. Yeah, this is the condensing unit. So at least when you're on the roof, you see what a condensing unit's about. So this is a rejection of heat. So it could be a condenser or condensing unit. The only difference is if the compressor is in it, it's a condensing unit. If it's just rejecting heat, it's a condenser. Again, you have it on the roof or maybe out the back side. So you see little split system Mitsubishis or something sitting out the side. That's where your condenser is, and probably your compressor.
What's the definition of a split system?
Okay. So I may have a slide, but I'll tell you. So split system is where my fan blowing the air into the space is sitting here, and my condenser and my compressor is located somewhere else. Where you have a rooftop package unit, it has a compressor, the condenser, the supply fan is all in one. So here, a lot of your IT rooms, we put a little fan coil in there, and we put the condenser, and you see refrigerant piping. So that's where we split it. Otherwise, the package unit is all together. No hard questions here. Okay, cooling tower. So again, these are associated with chillers. So you're seeing a bunch of water fans going through your big fan here, drains. So now I know typically, I mean there's exceptions, but I know I probably have a chiller somewhere. So again, this is rejecting chiller. So this is the other side of the split system. So this is a little, we can mount it on the wall, mount it on the floor. So this is the fan cooling the room. That condenser I had a couple back was connected to this refrigeration pipe. So a lot of times you'll see this just mounted on the wall in an IT room. Some small offices that they don't have anything nearby, they'll put this in the room and with a little split.
This just has, in this unit on the wall, just has piping with a cooled liquid in it. That's a fan across it.
Yeah, it just has a coil in there, and you got your refrigerant piping and a fan blowing across the coil. And the refrigerant refrigerant is creating the cooling. So there's an expansion valve. You got to deal with condensate because you collect condensate. So with something like this, we may have to put a pump somewhere and pump it over. So you have a fan, a foil, and you have to deal with condensate.
By the way, you can see this unit in our RIQ.
Yep, it's pretty standard, yeah. Okay, what do I got? Okay, so just a basic, simple ducted system here. So I call it out. So you always have to put a filter in front of your foil, your fan. You just apply to your room. This is a return duct. Sometimes you have a return plenum. You don't see this return duct. So air just basically goes into the space, goes across the ceiling, and you drop and pick it up. It's a return air plenum. You're going to have to deal with an electrical. He has to make sure he has plenum rated cables. This is what I call a ducted system.
Why would you have a duct?
It's VFC 2013-32893.
I don't know if you can, no, we can't mute them.
Some people don't like the plenum system because they say the space gets dirty up there and they don't know what's up there. But when you look at costs, you know, if I'm not thinking that turn ceiling and drop it in every one of these rooms, so there's a cost. But on a wood structure, you can't make a, so if it's a wood structure and they put a ceiling there, you can't make a return air plenum because it's a wood structure. Some beams I see they have to, maybe you guys tell me, but I see beams you have to fireproof them. So I'm not sure the issue with the beam.
Yeah, it's got to be non-combustible, which is why you got to use plenum-rated cable and stuff like that. It's got to be all non-combustible.
You also can't use the plenum for clean rooms, correct? It has to be a ducted system.
Oh, a clean room, I mean, yeah, it'd be a whole different game.
But for labs, you usually want to control pressure.
The labs we won't because we don't what's coming out of lab. You don't want to put across your whole ceiling. What we see is an opportunity for the job to save cost. You know, fundamentally, the decision of your cable is just a cost thing. Because otherwise, I have two parallel systems here I'm paying for, where my return could just drop in. Even this space here, you want to have supply, and wherever you're going to drop through the roof, you just have a return right there. Even if there's a ceiling there, if it was a plenum, I would keep the return there. Otherwise, I have to put all this duct in every one of these offices. So it is a parallel duct system. So again, if you're looking at something, it's on the roof. This is a package unit. So typically with a small package unit, so it's a 4x6 unit, small, you couple condenser fans. This gets one thermostat. So if you got what we call a package job, you're basically, if you want a zone, like you want this conference room to zone, it's a complete unit. You put a unit, you duct here, and you get a thermostat here. So this is what we call a single zone package unit.
This has the condenser, the compressor, the coil, it's all there, and just everything's created there, just push it through.
Exactly. That's the package part of that? Yeah. That's different than this. So here's a bunch of fan coils again. So these will be splits. A lot of times, if you do like high-rise, I guess even apartments, they stack them in a corner. So you stack these units. So these are fans. So these are stacking fans here. And these are just coils here. Again, they're single zone. Now we're getting larger units. So these are these big, you see them on the roof. It's a package unit, so self-contained, all the refrigerant, the control, everything's there. I have ducting dropping off the bottom, or I think a lot of you probably see a lot of side ducts, because acoustics, these big units, you really just can't drop straight down in here and serve the space, because the acoustics of the unit. So we try to go to horizontal duct on the roof, where we get low frequency breakout. If you insulate it, you get some high frequency attenuation. And then we can select where we drop. It's not over no sensitive areas.
Yeah, so
what does VAV stand for?
I don't think I have a slide for that. No, good question. Variable air volume. So it's a modulating system. So again, we're saving energy. We're not constant volume reheat. So you have VAV box, and I'll have pictures of that throttle air back. So I'll hit a picture of that to show more of it.
So this is serving multiple zones, multiple T-steps, like in a VAV, multiple kind of business.
Yeah.
Those typically have to have the reheat coils on
Correct.
each zone, correct?
Let me see how far I have to jump ahead. Not too far. Oh, that's not a whole bunch of energy. So here you go. So exactly. So now all of a sudden, with getting a VAV unit, I just bought all the thermostats I want. So all the zone control I want. I mean, it's all related to a cost. But now I didn't have to put a package for each one of these rooms. I have a large unit here, and I have these VAV boxes. So that creates a zone. So that little thermostat right there modulates that damper right there, modulates air. And then we keep it to a minimum. We always want to ventilate the space, so you stop it somewhere. And if I still need to reduce the cooling, that's where I reheat. So I reheat for interior zones. Just say this is even interior, but I want to ventilate this. So I'll have a reheat on this, but now I have an exterior, so I'm heating, so I'm going to reheat the exterior. So code makes you go down, what they makes you go down to they have a CFM square foot, 0.3 to the supply, but they make you go down to a certain number before you can reheat, because we're about saving energy. You don't want 50, so typically this guy's always producing 55-degree air. You can do some reset. So you just don't want to, just say this was getting 1,000 CFM. You don't want to heat all that 55-degree air up to 70, then heat the zone, so you modulate it down. And that's the VAV box doing that with the reheat.
Everyone understand that? Did someone not understand? I'm willing to bet someone didn't understand. So you're controlling the cooling. Temperature remains the same. You're controlling the cooling by how much cold air you're dumping into the space.
Controlling how much you reheat the cold air.
No, first you're controlling how much air you're dumping in there, and then if you're down at the minimum, then you start reheating the air. Okay, so what happens is it's going to cool, and if the room is getting too cold, you're decreasing the amount of cold air going in there, and when you reach a minimum, then the reheat coil starts kicking on and starts warming the air to get in there. And that's how you're controlling temperature.
Yeah, the first step is just reduce air quantity. Again, because you just don't want it. What we call CV reheat is you keep it at constant volume and reheat it, and you don't want to do it. It's not actually allowed by code.
Right. And the VAV stands for variable air volume. So you're controlling temperature, varying the amount of air.
What about the dual?
The other one is called the constant air volume.
What about the dual max systems, where they actually ramp it up 30% or ramp it down 30%?
Ramp what up or down? Sorry.
The min values for heating and cooling.
I'll get fancy on me, Sean.
You mean ramp the box up or down?
Yeah.
I mean, that's what you do, so I'm not sure.
They just changed the value, so is it, because I'm just kind of getting into it, so
Okay.
Siemens is trying to explain it to me, and I'm not quite understanding it. I just wondering if you'd heard of that before. Where they actually take 30% off the top and bottom values to garner energy savings. Not quite sure how it. So they're just changing the stuff.
Yeah, so
Yeah.
Pretty much.
Yeah, I mean,
That's those are the boxes that fluctuate.
So when my engineer sizes that box and creates a schedule, and I'm not showing him the answer yet. So we create a max value. The max value is basically the peak load. Like we size this room for putting 30, 40 of us in here, but there's 2, 5, 10 at times. So that our max value is based on what we think the solar hits us at the same time. Put 40 people in here, so that's a max value. So that's a max. My min is probably either my ventilation rate required for this room, or is if you're talking position, what I'm allowed to do is take it down to a min, and then if I need a heat, what I do is I turn on my heating valve and then bring it up. So again, I'm minimizing my reheat. So I don't know if that's the set points you're talking about, or it's just some strategy a control guy's playing with. Maybe that.
Yeah, I think they're trying to follow the curve closer to an actual curve rather than just jumping up and down.
Yeah, everything's moving. It's not, nothing's two position here. It's all proportional. I'm pretty sure I'm not answering you, but I'm gonna move on. So
You don't
anyway.
know the answer, Sean.
So VAV, this is what it is. Also, what the advantage, what we do is we have a pressure controller here. So we're saving fan energy. So while we're cutting all this air back, we're just not building static in this duct and keeping that fan going. So we have a VFD on that fan, and we're sensing that all these throttling back. So we're field is building up pressure. So we have a sensor, let's say, just right there, and then we start slowing down that fan. So the VAV part of it not only creates a lot of zones, the variable air volume component allows me also to diversify my load. Is we know at that side of the building peaks. This is our east, so in the morning we're getting sun here. We're not getting sun over there. So now I get a sizes unit, and I get to diversify this. So I know at 4, when you're getting a big solar load here, you don't have this solar component here. So I could downsize the total part of this unit, but if I packaged it, I would have to size a little unit for that peak and a little unit for that peak. So this allows me maybe go about 70–80% of the total capacity by diversifying these solar components.
How does the variable frequency drive know to slow the fan?
It's the pressure sensor I put. So I have an inch of water, let's say, and once these boxes start throttling back, that fan didn't know anything, so he starts he can't move as much air, so he's on a curve, and he just starts building more pressure. So that sensor says, hey, I sense that I'm building pressure, so he slows himself down to keep that pressure there. And that pressure is determined during air balance, so they know what pressure they need, wherever that sensor is actually, to satisfy all these boxes at peak. So it's an air balance function. I could guess and say about when we balance it, the balancer actually determines that set point.
Who provides the variable frequency drive?
That's
buys it?
that is a good point, because you know what?
Who buys it?
The electrician, the mechanical guys do this sometimes.
Oh, yeah. No, never let that happen.
Whatever Southland puts on their proposal.
But when you work in such a good construction company as Dome, they have clearly identified.
But we have the electrician and the mechanical sub-provider. We back it out of one or the other.
You clearly told us ahead of time.
David, usually we like to have the mechanical provided, the electrical wired.
Oh,
Eric, I know the answers to all my questions. I'm asking them for the group. If you want to answer to the group, that's fine.
Making sure you get it.
and I agree.
I've only been doing this 30 years, Eric. I'm fine.
Is that it? Just 30?
So, yeah, I mean, I think it's becoming more standard, the mechanical guys provide it, but years ago, it was, I want it because it's a cost thing. So, yeah, I'm seeing more standard is we're providing it.
Electrical installing.
Yeah, that seems, but years ago, it was.
Can we talk duct detectors next?
Oh, don't forget the condensing, the condensate piping.
Yes.
Oh, Lord, you have plumbers thing, that's not there? You need to control your
No, we have
plumber.
mechanical subs.
Yeah. So, smoke detectors pretty much, we used to provide them, but now they're all addressable and they're part of a system, and it's pretty, I don't think we have those problems anymore, but we used to have those problems. Now, it's part of a whole system, and it's almost never the mechanicals anymore.
From the mechanical perspective.
Yeah, I actually went past that.
Unless you physically install it in the duct,
Yeah.
then you.
Yeah, typically we install it in the duct, but it's provided, because again, now they call what they're addressable. So it's all linked to a system that we're not involved in. So we're typically the installer.
Right. So those are 3 key points that you need to watch out that you don't get missed. Variable speed bands and the duct detectors, and plumbing, maybe that's not a problem anymore, but it sure used to be 10 years ago.
Oh, really? That's honestly?
It's still a problem.
Really? Yeah, I have to admit,
But it's usually on your drawing,
yeah.
not on the plumbing drawing.
Right. Exactly.
From a GC perspective, one of the major things I see issues with a unit mounted on a roof, like especially large ones, is maybe the vibration or noise. So you should look at and ask the question, hey, if you're doing a down discharge, has the contractor figured for potential breakout radiated noise that's all hit the space, or are they going to need a sound consultant, or do you need to have vibration isolation on it? Those are the big considerations. You're asking a contractor what he's providing for that. What has he done to take measures for it?
By the way, does everyone know what condensate piping is? So then if I ask,
Something the plumber should ask.
So,
Yeah.
so everyone knows what condensate piping is, so I'm gonna ask Jackie, what is condensate piping? Aha! But you didn't raise her hand. Sean, what is condensate piping?
It's the drain from the condenser.
Evaporator.
Evaporator.
Sorry. Yeah, it's that copper pipe you trip over on the roof, coming out.
And why is it there? What is it? Why is condensate? Or what is it?
Because the only way you get heat loss is if you evaporate it or you're using a compressor to pull the heat out of the system.
But I'm wrong.
Cooling coils in an air handler produce water because of the fact of taking the air moving across the coil.
Yeah.
Is condensing water out of the air. That water will drain into a pan inside the unit. That water needs to be taken away to sanitary, not storm, drain piping on the roof.
And that's city by city.
And assuming that it's on the roof, if it's a split system like you have in a
Take it to sanitary.
practice.
Let anybody tell you can just dump it onto the drain and send it down the storm. They don't allow it.
I would say just not to take that totally carte blanche, because that's our biggest, I know this guy back there, I recognize his voice. But it's a good point, is talk to your city, because we're in San Francisco and they say wherever. Because you know what? It all shows up the same place in San Francisco. They don't have a storm system, So, and if you're down in Mountain View, I make my plumbing engineer stay on top of that and call the city and see where it goes. But I would say probably mostly sanitary. I don't agree with it because there's no contaminant. Why are we treating it? It's condensed air that they say, well, maybe your coil will leak oil. They get that extreme.
Right. But ultimately, wherever the cooling coil is, that's where you're going to get condensate.
Yeah.
And you got to watch out for it.
And a lot of times you're never going to see condensate come out because the coil hits dew point, so you have to have the conditions in outside air that have a moisture above what we call dew point. So there's probably around here, 80, you're not condensing any moisture.
So I'm going to give you a warning. I'm going to ask if everyone knows it. And if everyone doesn't raise their hand, then I'm going to ask someone the question.
Yeah, by default, just raise your hand.
It's an easier world.
Yeah, just raise your hand.
So this is just a simpler picture of what we talked about. Again, I have a bunch of boxes here.
Who installs, who moves, who puts the thermostats in? You or the controls?
Typically it's controls. Typical controls. Yeah, I think on one of my last slides is where can you help us? Is control the controls contractor, please.
That's where you guys want it, not where, like.
Carry the controls subcontractor.
We can't control them.
Neither can we.
You're right. Oh, we all know. Yeah. So this would be something if you're looking at a drawing here. So basically, you see this. I don't see where the air gets into the space. There must be some drop somewhere. Right, there we are. So here's the zones. Typically, they're trying more to keep the zones above the offices. But this drawing, again, is a schematic. It's on a bunch of zones. This is a layout. So you look at a mechanical plan. You see what this box is and all these little diffusers. Now you know you're looking at a VAV box. And some type of symbol here that would be, this means this box has a reading coil.
Who picks up the water for that? The VAV?
That's under the mechanical, HVAC non-plumbing. So that's part of the hydronic system that the mechanical guy picks up. Not the plumber.
So
yeah.
the plumber? Or
Not the plumber. Not the plumber.
You've got the wet side, you just don't have the condensate. That's what confuses
Exactly.
Why don't you've got some copper, but not all the copper.
I'll help you on that. Okay. No, I'm gonna say that pipe slopes and goes to a drain. And I'm gonna say my other pipe's a flat pipe pressurized system. You go for
Pipe is
that?
pipe.
Yeah,
The
and it's on your
contractor.
drawing.
Yeah.
Hey.
Pipe is general contractor.
It all depends if the condensate was put in correctly.
I told I was walking in a friendly environment. Next slide. Okay, just a bunch of shiny stuff, not really much here, but a bunch of ductwork that mechanically, actually, I don't think we could dump any of this on the floor.
Square versus round.
Okay, there you go.
But why?
The round, why? Cost. We have machines, so actually, we're a good team here.
Yeah, we are.
Okay,
That's why I sat next to you.
I have better pictures. See, you see all these little ribs here? So we have a machine that would just, we call this spiral, so a spiral. So we have a machine that just spiral this thing out. It keep going, but typically we do 10-foot lengths, you know, if we have an opportunity to go longer, you will go longer. So it's almost no manpower involved, not a lot of handling. The machine just spirals it out and we bring it out. Where a rectangular duct here, first of all, typically the joints are in 5-foot joints. And now we do have machines that will cut it and break it, and that creates some of the cost. So when you're saying we're too expensive, we're buying machines that do this. Okay. But anyway, now I'm handling 5-foot joints, but I'm handling 4-sided joints here too. So I have a lot of field work here too. And now I have more elaborate support there. I have units starting all here. A lot of time I get to strap this stuff. So it's not only the cost of the material, but and making it, it's actually installations that are cheaper also.
So you explain why do you use round duct, why do you use square duct or rectangular duct?
Typically space, you know, it's you know, when I have a 20, because any architects in the room? So what architects love high ceilings, and they just try to shove it. So they don't allow me. The problem I have to do, so I may have a 40-inch round duct, but you're going to see me with an 18 by 60, because it's fundamentally, it's most times space. Because the problem with rectangular duct is you get those real wide piece of duct, and what they want to waffle, so they want to create noise. They allow breakout of what I call it breakout. Well, round duct, it's stiff, it doesn't break noise out. So if I ever really went through a real noise-sensitive area, I'll round duct it because it won't allow the noise breakout. So it keep the noise in, where rectangular allows it to come out. So that's the problem I have to deal with. But rectangular is, if we could do round, we prefer to do round.
What about the spiral oval stuff?
Yeah, you don't see much of that anymore. Yeah, I think, I'll be honest, I've done very little of it. Early in my career, the company they had a machine, but they sold it.
Is it bad?
Yeah, because you know, everything's about cost nowadays. So if there is fundamentally something real about it, it would be there. I think where you get the advantage, if you're running long lengths without fittings, because the fitting to an oval is a pain. So there's a lot of costs. But if you're running 400 or 500 feet and you just join it together, now they could do 10-foot joints. They could oval. I think that's where I told there's costs. But when you have to put fittings, oval fittings are. So that's where they see it. You know, where you don't have a lot of taps into it, a lot of fittings.
What about flexing them in?
We'll see. I don't remember all the slides. This is just the VAV box we were talking about. Basically, we have an actuator, we have a flow measure, and we have a damper. We like to keep some straight entrance into this so we get good flow measurement. But at times, you know, you almost have to crank it in there. And they have, when the bouncer, he puts a correction factor on that. So, but VAV box.
Who supplies the actuator? You?
Controls guy typically.
Okay, so you supply the VAV box, the control guy has to put the actuator in, assuming the control guy has to program the actuator, correct?
The controls to it, right?
And then on the VAV box, on the reheat coil, who supplies and who programs the control valves?
typically control guy supplies the control valve. So we'll mount it, we'll pipe it, and then he'll control it. The controller here, the controller there, he's controlling both the actuator and the reheat valve right there. So he has the controls right there.
So what's the reheat valve?
Okay, I'm helping you out.
Don't raise your hand now.
I'm helping you out.
I know.
So here's the piped up reheat, VAV reheat. Now you see the piping here. There's a coil. That's a Belimo actuator, so the valve's right under it. So Belimo's pretty popular out there. So if you see that orange thing, then that's probably an actuator on a reheat valve.
So does anyone know what a reheat valve does? Other than the pain in the butt in the back.
Anybody else know?
Go for it then.
Want me to tell you what it is?
Yes.
So it's a motor control ball valve that varies the flow. See that jacketing terminating?
Yeah, I can know. It's very real.
All the other valves in there are like isolation valves. Off of the controller that's mounted to the side of that. That cables back to the main controller, so then the main controller controls each one of these depending on the zone control that's set off the thermostat. That's what I'm saying.
Someone moved the speaker, the microphone.
Valve opens up.
Well, it depends. It depends on the airflow of the room versus the heat setting you're looking for. It may do one of two things. It could throttle the air a little bit and open the valve a little bit. If the air is not coming through enough, it'll open the heating valve a little bit more. But it's all working in concert with the air flowing through it versus the temperature setting.
But simplistically, for the non-mechanical engineers in the room, hot water runs through the pipe, air blows across it.
Gets warmer.
It's warmer.
There you go. And a lot of times you're cold and you push that button and try to change it, and two things happen. We took control away from you, so you think you have control.
Yeah.
Or
Like being
they
married.
yeah. Or they just give you a degree or two of reset. They don't let you go whack with it.
How different are these in different parts of the country? If we're in very cold country, is it much different of a system, or basically across the board it's all the same, just our climate allows it to be more efficient?
Yeah, I think the systems are the same. It's more how we construct, where we put, like back east and a lot of, they don't believe how we just throw everything up on a roof, you know, because they worry about snow loading and all this other stuff. But, you know, modulating air and reheating air and all that, I mean, nowadays, across the board, they look at displacement air and do all these other things. But, yeah, fundamentally, it gets close. Now they have real cold zones. A lot of times they have to deal with a separate perimeter heat. Just not going to heat it with the air here, so they deal with heating different ways in the perimeter. I'm born and bred here, so I only know this climate. So just more, you see, I wanted a slide count, so I did that more the same. VFDs, so we were talking about supplies, so variable frequency drive. So this is basically what ramping your fan motors up and down. One thing the new code change is they're demanding on a smaller little package units to put VAV on it now. So before, all package units are typically constant volume. I think the new code says it's 6 1/4 ton, now you have to go VAV. So that's a change happening July 1.
If you guys install it, do you guys do the programming on the VAV and adjust it?
The controls contractor would be doing the,
On the VAV? No,
on the VFD, yeah, because he's controlling it. He's, no,
I would
disagree, but.
my service startup, you're gonna put that on my service startup?
No, actually, what I would prefer to do, and what we do here at Genentech, is we have a separate VFD, startup contract that actually does the startup and check out it, and separate drive.
Yeah.
And I put it on you guys in the past too.
I would
To
agree.
make sure it gets done.
I'm a mechanical guy, so I lie sometimes. So, I would agree that my service startup would, the controls guy, he needs to start up his unit and get our unit running. So you're right, he's gonna go mess with that. You're setting me up.
No,
I'm joking.
I know,
we're
playing
down,
straight,
we're
man,
down,
because
we're down.
we ran into that where it was that little bit of gray area, and you guys stepped up and said, hey, we'll get it running. But you know, obviously, if you have any major controls, obviously the Siemens of the world are going to come in and do it. But you guys got it going.
Because we got to get the unit going, so we get. Yeah, you're correct. You're right.
If you ask him before you issue the subcontract, he has it. If you ask him after
he doesn't.
He doesn't have it.
See, what he identified is I'm just a dumb engineer that sits in my office. Okay, so
So we should have asked Glenn that.
yeah, yeah.
Glenn's more political.
Yeah. I get in trouble for not being political. Breakaway of unit, you see, so supply fans, filters, coils. God, I don't know what everything, they got like everything on this picture.
That's a mixing chamber right there.
Yeah. Mixing, I wasn't gonna get into the cuts of an economizer and all that.
Well, why don't you tell us, are you gonna tell us about what economizer is?
Now you are.
I am now. I don't know what, I had a slide on that. Okay. We live in a world of economizer right here, so we want to save energy, right? So it's cold outside, so why in the hell am I going to turn on an electrical meter and put a cooling coil and go when I got 55-degree air out here? So economizer is saying, I got free cooling, so we open up a damper, it takes to 100% outside air, and we put it in here and we exhaust it out. And so it's free cooling. And then we have what we call integrated economizers is, let's say it's too cold out, so it's 40 degrees out, but we don't, you guys complain when we put 40-degree air in here. So we're gonna bring back some return air and we're gonna blend it to create that 55, so that's integrated. So what happens now, I'm dumping all this outside air in here, I have to get it out. So typically we either have a return fan or a power exhaust fan, and we put a static pressure controller in the building, and we sense that we're blowing all this outside air, and we sense it by we're trying to blow this up, so we see the pressure, so we use that pressure controller to exhaust that free air we got. Is that close enough? Okay, good.
Is that the same, so the air you're bringing out on an economizer, is that the same thing as makeup air?
No, good question. Makeup air is, on a 90-degree day, I have to give you guys fresh air, I just can't keep recirculating it. The theory, if I recirculate it, I'm not spending as much energy because I'm not putting 90-degree air, but we have to ventilate it. So there's, nice thing about California, ASHRAE, and there's a ton of people out there, but California has codes for minimum fresh air for spaces. It's either based on square footage, occupancy. So it's like this room right here. Mostly the older days, I would have to count the seats and always dump all this fresh air in here. So now code is requiring like this. I have to put CO. So the sad part of that, I would have to always put a lot of people in there, so I have to put, let's say, 500 CFM fresh air in here. But when there's the two of these guys over here talking about you all in here, and by themselves, I'm wasting all this energy because I'm taking this 500 CFM, I'm reheating because I don't need it. So now we're CO2, so we're not allowed to CO2 sense this room. So we're outgassing, so we sense it, we ventilate it to a CO2 sensor. About 1,000 ppm is about the number. Some people say 700 to 1,000 above the ambient. But so now I could just ventilate this what's needed, not just to overventilate and waste a lot of energy and reheat.
Is that common for CO2?
It's now it's going to be it's been mandatory for certain spaces. It's based on a density, and you know I let my kids do most of the work anymore. I think it's 40 square foot a person, and above I think 10 people is a space that requires CO2 sensing.
So, but what I'm kind of hearing from you is probably within Title 24 coming through, more than likely you're going to see more and more of those CO2 sensors. So instead of going standard square foot, dumping 500 in, continually dump 500 in, they're going to look at the CO2 count. That way you can minimize the amount of air coming in, because obviously you can recircuit and cool it, keep the cool air recirced versus bringing, like on a day like today, maybe 70-degree temperature in, and having to cool it.
You're just trying to, because what is, you know, I talked about a VAV and a minimum. I was having to stop old days at 500 CFM and start reheating. Now I could take it down to 150 and reheat there. So it just, that savings. And then if I was in a cooling mode, I was going to have to cool that 500. So I was spending mechanical energy to cool it just for me to come in here and reheat it. So yeah, the July 1 Title 24 is locking all of that up. So everything's about energy, and there's some changes on that.
So basically, the new Title 24 is making things far more complicated. The systems are going to be more complicated. We're going to see more CO2 sensors, more variable speed fans, and things like that to save energy.
Yes, and I'll lie to you if I tell you I'm on top of it. You know, we're all. It was supposed to come into effect it's called 2013. It's supposed to come into effect January 1. Now it's July 1. The state's not. You're going to find out. The state's not ready for it. The cities are not ready for it. No one's ready. I just went to a seminar a couple weeks ago, and a guy that's involved said no one's ready for it, but someone high up said it's happening.
Ready for it as far as to review it and make sure that you're doing what.
Yeah, and again, I make some of my engineers read this stuff. I don't, but there's supposed to be kickoff meetings. You guys are supposed to have kickoff meetings with all, and it's supposed to be documented.
It says it in the Title 24.
Yeah. There's certain type of and now there's a lot more testing of the equipment that's required. Right now, NEB, TAB, they're all trying to get certified technicians for certain testing. They're not ready. They're not trained. So that requirement, I think they either pushed out a year from July 1 or a year from January 1, but because they don't have the people ready to do what the state is requiring.
That's the plan.
Yeah. So, and they're making me put a lot more documents on the plans. You know, before I could just put a couple of MEC ones. Now we're having to put all these performance testing on the plans. So, and no one's ready for it. We're all gonna, it's like anything, building codes, building inspectors, as they learn it, they start enforcing it.
Doesn't the new Title 24 also require peer review?
Yes, they do. And you know what? That's not going to happen until someone figures out what that meant. But yes, it does.
So who doesn't know what peer review is? Oh, now I'm getting more hands. So who knows what peer review is?
Peer or third party?
Well,
It's the same.
Well, no, because you could take it to, so let's say Southland does the design, and we want peer review. His peer is your competitor. So now I'm taking it to your competitor to say, hey, review their drawing. Third party is that. It's a third party independent. I would hope third party would be independent, and that's a mechanical engineering firm, let's say, that doesn't necessarily do the install.
Yeah. I was taking it to more extreme. Maybe it's just one of the guys in the office. But, no.
I don't think that's like the fox watching the hen house.
It's some guy down on the pier.
to the best of my knowledge, it's just another company.
It'd be a third party. It'd be another. We're not going to take a competitor. You know, there's some guy. If he's smart and he has a stamp, he's going to make a business of this.
Yeah. stamping.
Yeah, they're not aiming, no, this is.
Good, Mark.
Looks beautiful. What did you see? I don't know.
But what is the purpose of this peer review? What are they trying to accomplish by doing that? Or what are they stamping saying they looked at it?
Yeah, it's a second set of eyes confirming that you're complying,
Are they help?
Complying to Title 24.
Compliant to Title 24, that's it. So they, maybe it's trust, maybe it's just a second set of eyes, but it's just, they want someone to look, me just not go walk in, I got you covered, So they just want another set of eyes that is code compliant.
Which is weird, because that's what the city is doing, so.
Yeah.
They don't have the bandwidth to do that kind of review.
Yeah,
So,
they're.
to get back to the implementation, do you feel that it's gonna be local jurisdictions that are gonna be ultimately implementing this and verifying this?
I mean, it always is. What the guy's saying is they haven't been trained. They haven't hit the seminars. They don't know what they're getting. So, it's gonna be totally in. Right now, I am swamped in issues because everyone's trying to get in before the new Title 24. Because what I was told, that electrical is going to have a big cost impact on you guys.
That's what the electricians have said.
Yeah.
They're already raising their prices.
People are talking for lighting, and I guess they have switching for plug outlets and doing different type of lighting. They're talking 20-25% on the lighting and stuff. So, we're inundated right now. Everyone's trying to shove it in. Never too swamped. What's that?
On an existing build-out, basically, is it from your VAV that you're changing out, or is it all the way up to the package unit?
I think they're not gonna make me, that's another thing, the package units are a lot more efficient. They're requiring more efficient units too. But if I'm doing a retrofit, they're not saying pull that thing off the roof. It's now, but if I need different types of controlling that VAV box, and I'm changing stats, those are gonna be code compliant stats.
So if like a multiple suite building, there's a chance that you touch one piece, how many pieces are gonna be affected?
You know what? That ain't written, so you're at the mercy of the building. Yeah, they don't, that's not written, yeah.
So how are we gonna know that? That's the biggest question is so you know that in the old days, certain dollar amount, certain square footage triggered that. So we're now sitting in front of the customer. How do we politely go, we just don't know until we go down to the city that we're gonna, all of a sudden, they're gonna go, sorry, you need to meet Title 24. Yeah. Your schedule, your cost, everything's gone.
You're gonna go there before you meet the client. I mean, that's the right call. Get an interpretation ahead of time.
It's almost gonna be, sound like an 88, 20%. Sounds like they may be able to.
Yeah, what I find is these guys make up a lot of this stuff, because that's the problem. What's code about? Code's vague for the purpose to allow interpretation, and is purposely made that way. So, and it's always a challenge to us, because you deal with different inspectors, and it's like, come on, dude. But, that's how I interpret it, so it's set that way. So now you see all this piping running across. Now, this is what we call an air handler. I don't have a compressor in here with refrigerant. You're not going to see any fans blowing heat, because somewhere else I generated the cold water for the evaporator. So all of a sudden here, this is just a fan and a filter box with a coil, fundamentally. They could get humongous, but it's that basic, So I got rid of a compressor, I got rid of the condenser fans, I got rid of, there's all the controls related to operate that. So it's a smaller box, because I don't have to have all that in there. But now somewhere I have a big chiller yard and a cooling tower that creates this cold. So if you're seeing this on the roof, you know that this is an air handler, chill water air handler, and if it had 2 other pipes, then it'd be heating also.
And those will always be labeled. You guys can walk up to a roof, heat hot water supply return, cooling water supply return. There's labels everywhere. What is it? 10 feet or
I think it's 20 feet. Yeah, I think it's 20 feet and change of direction. exhaust fan, centrifugal exhaust fan, no stack, they're in middle construction. Actually not a good inlet condition, so this fan, as an engineer, I have to derate the performance of this. But you know what, roofs get so tight, you know, I never get to do everything I want. Yeah, you can. Mushroom fan, so this last one, what I call the centrifugal fan, that's just a mushroom fan. Kind of see it. Okay, what did I have here?
It's got the air handlers.
Yeah, so I have this down below, so here's my chiller, compressor, condenser. So how do I reject heat? So we always have to reject the heat. So this chiller was creating chilled water as we need it, we reject it through. So this is condenser water piping. So the chilled water piping was the cooling mechanism that went to the air handler. Condenser water piping, you'll hear it, is the one that goes to the cooling tower. So this is where we reject our heat for the system. So like back east, where we talk about what they do different, they put a lot more inside a building like this, where here we put a lot more out in pads and on the roofs.
You gonna talk about water-cooled versus air-cooled chillers?
Yeah, I think I got a couple of those. If not, oh, there we go. So here's an air-cooled chiller. And, so water-cooled chiller. So this is a small, and I have some pictures down the road. This is a smaller chiller, smaller footprint, because I don't have I don't reject the heat with the cooling mechanism. I have it up on the roof. I pipe over to it. So this is a water-cooled chiller. So when you see this, so typically this is what you'll see on a roof. You see all the compressors are exposed here. You see a big tube, that's the chiller barrel. But this is the condenser. These are the fans, so we're drawing air and rejecting the heat. And we're creating chilled water here. So this is an air-cooled chiller. There's limitations on another thing on Title 24, and I think they strengthened it up. They used to say no chiller over 300 tons to be air-cooled, because these aren't as efficient as water-cooled units. But so we have a bunch of multiple 200s and do it different ways. So now I think they just said no more than 300 tons of air-cooled chiller, period. Again, these are clean, right? That other one, I had to place a cooling tower, I had to get a drain, I had to pipe water over to it, we had a bigger footprint. So this is just a packaged chiller in a sense. So these, nice part about these, we could set them wherever and just hook up. I don't have any condenser water piping, I have no water treatment, I have no drain, I just get to hook up two pipes and deliver chilled water.
They're not as efficient except on cost. Cheaper.
And once you go into water-cooled chillers, you know, he said water treatment. That becomes a big deal.
Scale it.
Yeah, because you got water flowing through this iron pipe, and you know it's constantly corroding, and
it's exposed to the elements. There's a difference between closed systems and open systems. And a closed system is something that's not exposed to air. Open is like open water, cooling tower. That water is exposed to air, so it's taking all the junk, whatever.
Plus you have evaporation, so you're using water.
Yep, the evaporation, we call it cycles of concentration, so I have to keep draining water, because you keep evaporating, and if you just don't get rid of the minerals, they just keep accumulating. So I have to keep my cycles of concentration down. I'm bleeding water, so I'm bleeding what I'm leaving in the tower basin. And what's the number one? Owners don't take care of this well. You know, this is where the problems, agreed, but when you look at efficiency, and that's what people are looking at, a water-cooled system is more efficient. I mean, trust me, they're working real hard to make these more efficient, and they are. They come a long way, but.
Where do you draw the line where you're going with a package unit up on the roof versus going to a water-cooled? Assuming that you're not talking space, meaning obviously, if you don't have space in the back of the building for a water-cooled, you don't. Now you have to start looking at package units. But given that you have a choice between, okay, we got room on the roof and we got room in the back, where's the choice? What is it? Cost, efficiency?
Well, 5 to
it's more what I'm doing in the building, like an office building, I mean, unless it's a massive, awesome high-rise, then I just can't put everything on the roof and get it down. But if I have space, is labs where I have a lot of outside air, you know, then I'll probably, we look at chilled water, so I'm looking at more, at least what we're doing. Office units are pretty much all VAV package, but where I get into my labs, where I have a high amount of outside air, then I could put all this capacity in the chiller, and I just pipe it over. So that's how I look at it. Office, you know, or now owners, they look more global. Now I have a campus, I could now not put all, now, because it's maintenance, when I put all these units on the roof, I get a lot more maintenance. So if I have a campus, I could put a chilled water plant here, and then it's just a bunch of fans on all these roofs. So I have to pipe it all over, but I have less maintenance because they're only dealing with a fan, not all the compressors, all the condensing fans. So, like Genentech, they're trying to go more campus-wide right now. They're trying to create a campus chilled water system. They're looking at that. Stanford does it, but it's bigger places.
If you got a maintenance department, it makes sense to go water cooled. Yeah. But if you don't have a maintenance department maintaining that water cooled system,
yeah,
it can be in deep shit.
We only have a couple more minutes. Do you want to go to the slide where what you do to help you guys, the mechanical contractors?
I'll be honest, that was probably one of the other areas I failed. I didn't ask anyone till late, so I kind of created it. So
yeah,
that's fun. An engineer's perspective. So here's some water cools. I think towers, so something you see, big filtration system, large tower system. Condenser water piping. It's uninsulated is condenser water piping, insulated is chilled or hot.
So does people know what the difference between condenser and chilled is?
Rainwater?
Condenser water versus chilled.
You could say insulated or not.
Condenser water is the water taking the heat away from the chiller. The chiller is taking the chilled water. That's what's going out to your heat.
Condenser goes to the cooling tower, it's rejecting heat.
Those are boilers. That's how we make hot water.
Steam plant, okay. Title 24, kitchen, another thing, kitchen. They're almost pushing to go VAV on kitchen hoods now. There's other strategies, but they're not allowing you just to condition all the makeup air. They're not allowing it. So you can't just take 10,000 CFM and condition 10,000 to make it up. They make you steal so much of it from another servery area, another area, or they're making you basically go VAV on kitchen hoods. So that's one of the changes coming. Economizers, some other stuff. Better glass, better walls. Okay, how can you? Okay. Yeah, I did ask a few people, and it was interesting. You know, I thought it'd be a construction component, do this. It's more planning a job. So, you know, working together as a group and helping creating that schedule is that, you know, you hear all the lean and all that talk out there. It's more us working together. Hey, if you could push this back, this will help me get this done more efficiently. And it's more, you know, the old days it was, boom, here's how it is, suck it up and get done. But that was one of the big statements. And that's a lot of people, what I find is talked a lot and played out from 10 to 50%. No one's arrived yet. You know, you hear all this lean collaborative talking, but a lot of times it still becomes construction. But it's just us working together, except that, hey, we are a team. We're not just a sub. We're a team, and let's work it out together.
So what's helpful is like doing a pull schedule. I don't know if everybody knows what a pull schedule is, but it's
I don't think you guys use it very much here, but we are going to use it on the B47 job. So, I mean, if that's something you guys are interested in attending just to watch it, it'll probably be good for you guys.
What I find is, you know, we get on a job, the superintendent provides a schedule from his interpretation of what he sees about the project going, but without a lot of detailed input from mechanical, electrical, and other subs. So if in the beginning of the project you spend that extra effort to really sit down in we call it in the big room, like a room like this, and everybody looks at the job and says, hey, add more detail to the schedule. And then that's the way you can look for efficiencies. Like, well, if you're going to have a guy out there doing this work, then if we can share a lift, or we can, if I know that, the whole job for all the crews is more efficient, which will help them and help you be more efficient. So it's to me, that's what I've seen in pre-con. I do a lot of pre-con work, and I see that as being a big help for the process and building efficiencies throughout and trust. And it helps you build the relationships at the same time. So everybody's in this room together trying to collaborate, and you're building relationships with all the different players, and you get to see what they're thinking, what their personalities are like. So later on, it's easier to communicate with them.
Look aheads, that's just fundamental planning. One of the complaints is when we do the 3D coordination, you put out the docs, we're doing 3D, and all of a sudden the sprinkler guy ain't doing it, or the electrician only does it up to a certain size conduit, and then it's just more conflicts. And then not holding people accountable. It's an MEP job to stay on top of it, because you're detailing to hit inserts, you're detailing to, load a floor. So staying on top of that detailing process that we see, we see a bunch of kids thrown into these MEP positions, and they don't know construction, they don't know how to control field guys to get things done. And so we're virtually drawing it, but in real life, it's related to your schedule of install. So more of that could be controlled. That's me, just shafts. I see always bringing that concrete, because that's where we're setting all their supports for ductwork, and that gets, sometimes you see our big steel going into the wall and you're caulking around. That didn't happen. We talked to the architect and tell them, but it didn't get communicated to the structure. So those things you can help during the design process, make sure it's covered before it becomes a field problem. Yeah, this was more just one of my guys saying, it's more helping you guys. We are in a job, and they didn't address miscellaneous steel, and the steel guy was just reaming the general on all the changes for miscellaneous steel for the air handler. So the costs were just, so negotiate what miscellaneous steel and how much is ahead of time. Because he just watching them rake the general. And priority walls, that was, to find that ahead of time, it's not 36 inches and every wall's a priority wall, and the guy builds all his walls, I guess us mechanical, we just, everything's a priority wall, so to find that ahead of time, it would help us.
Everyone wants to go in first.
Yeah.
Whoever's first has the lowest labor costs. So.
And so that's a priority wall. So if you define it ahead of time, no, it's not, and we put it in your contract, or we put it in part of the bid documents.
Getting back, before you leave that, let's go back to the
Hey, I like this car, come on. Okay.
So one thing about, everybody should be aware of, on the 3D coordination, some of the things to look out for, graded lines are a huge issue with collisions with other MEP trades, because as you can well imagine, graded lines mean things have to flow through the pipe without pressure. So you're always going to run into some kind of conflict with a graded line. Storm lines from your roof drain, graded lines from your bathroom cores, and other areas that have to be, careful with, you're looking at a job, make their way out of a main duct line or some other main utility that's coming through that's colliding with it. So focus on those kind of things first, and usually a lot of your headaches go away when you take care of the graded line.
So who doesn't know what a graded line is? Cool. Sean, what's a graded line?
I was raising my hand.
You were?
On the inside.
On the inside.
Okay.
You want me to tell Mark? So,
No, I don't want you to tell them. I want to pick on someone who didn't raise their hand. Who didn't raise their hand?
They ain't telling you.
Keith, did you raise your hand?
Yeah, I raised my hand.
Right answer.
Ivan? So all you guys remain silent until I ask what the graded line is, huh?
No, that You know,
It's a valid stretch.
I preach at my young engineers, you know, like, I'll play the dumbest guy in the room, because at the end of the day, I gather it, you know, play dumb, you know, because down the road, what I tell them, they get to sit in my office and I eat bonbons all day, because I asked all the questions early. You know, ask the questions, really, you know, be that irritant guy that's in there asking a question, because you're educating yourself.
And the beautiful part is you ask the question and half the people in the room won't be able to answer it.
Right.
So you're not that dumb.
Oh, I know that. Play it, whatever.
Exactly.
Because you want to take his job right there, and the guy that got all the answers, and the guy that was that guy, you know what, you got that knowledge, and knowledge is what gets you there.
Right. And not being afraid of asking questions is what's going to get you there. I mean, especially when you got an owner talking to you, you know, and you're trying to bullshit your way through by not knowing what he's talking about. You know, it's much better just to ask the question. So I'm going to go ahead and pick on Heather. What's a graded line? You didn't raise your hand.
I didn't see her hand.
I didn't see her hand raised either.
Please do tell us.
Okay, Matt. I'm going to pick on a senior person. What's a graded line?
Slope line, unpressurized drain line.
Exactly.
Yeah.
That right now.
So does everyone understand what a grade line is then? It does, huh?
They're deceiving, because you look at a plan view of something, an MEP drawing or something, all the lines look the same.
And what's the normal grading, by the way?
A quarter inch,
I didn't hear you.
quarter inch per foot.
Yeah, quarter inch.
Jurisdictions allow an eighth, but that's.
Yeah, quarter inch is normal.
Does this system here have graded lines? Depends if you're parking on a hill or not.
I thought, hey, you know what? It worked. Generator doing his window shaker.
Hey, any last questions? So if you guys have any questions on your projects, it's a good idea to always ask your subcontractors, and even like go up to a field guy and be like, what are you doing? I do that a lot. Sometimes they look at me funny, and sometimes they get really excited about explaining it. So I think it's just the best way to learn.
Yeah, I would say something like this is greatly helpful for everyone. I think it was extremely well done. But it is about being in the field. A lot of this could have went over a lot of people's heads, but now that you grasp a bit more of it, when you're in the field, everyone likes to talk their trade. And that's when you learn. If you can get the one-on-one, just take a second to ask the guy, you know, doing an install, hey, if you got a second, I'd love to have some more information on this. This is a great ability to kind of get an overall grasp of something, but when you're in the field, that's when you ask the questions, and that's when the dumb questions are great to just keep firing and firing. There's nothing wrong with being intimidated and not knowing a lot of this and asking question after question in this type of, I don't understand this, I don't understand this, I don't know that. But take this in, and then when you go out in the field, get more. In construction, you just keep building on information. It's how you learn. You don't learn it in one day. You learn it over and over. Each job you're on, you should be taking in more information and building on that pyramid of construction knowledge.
Right. And you'll build up a relationship when you start talking to them. You know, everyone wants to. And that's true on the owner side too. You know, if you're working in a lab and you're trying to figure out how to do that, you know, ask the user of the lab what they're doing or how to accomplish it, what they're trying to accomplish.
I was with the owner at 6 o'clock last night, principal engineer, and I go, how the hell are we going to do this? You know, and he has process scientists in there, and we're figuring out. I didn't try to fool it, you know, because I didn't know. So, you know what? I still ask. And field guys they gladly help you. You're right. And the relationship, you know, because otherwise you're the guy with that hat and your little board, you know. And, you know, when you're talking to them, you know, it creates a relationship. No, I agree with that.
I'd rather see you guys ask questions as you don't know what's happening in here. So. By the way, we didn't even talk about constant volume system. So.
She yelled at me and told me to spin through everything.
Well, I'm just saying we need to probably do another one on constant volume system.
Okay.
Thanks.
Okay.
Mark,